Okay viewers, welcome back to computer networking classes. In previous video, we had studied about estimation of times, intervals and flow control techniques. In this video, we will be talking about TCP connection management. So TCP connection is done or synchronized by SYN bit and tear down by FN bit. So in step 1, synchronized bit is set to be 1. As you can see that in step 1, synchronized bit is set to be 1 and a random number which is client ISN is taken by the client and set by the sequence number. After that client will send this packet to the server. In step 2, server needs to accept the data and send back a packet with requesting another packet from the client. So here also SYN bit will be made 1 and a random number which is server ISN is taken and made sequence number. After that acknowledgement is given for client ISN plus 1 means he needs next packet. After that transmission of packets will be done with sequence number 0. Once a synchronization is being made between two hosts, synchronizing bit will be erased to 0. In step 3, as we can see that synchronizing bit is cleared, anyone here client or server can terminate the connection using fin bits, mean finishing bits. After finishing bits are sent to the hosts, an acknowledgement is he needs to wait for an acknowledgement with the other host. If an acknowledgement is sent by the other host, means another end, then it will wait for some time and then connection will be closed. So here client or server anyone can terminate the connection using fin bits. So talking about principles of congestion control, so there are three principles or three scenarios. Sorry. So there are two senders as router within finite buffers. As we can see that host A and host B are connected via a router to host C and host D, and host A is sending some data with application layer lambda in is the transmission rate and R is the link capacity. This is the link. So R will be the link capacity, and host B, in meantime host B also wants to send some data to host C. So at this time these two will share the link which is connected by a router which is having infinite buffer. So as we can see that the link will be equally shared and the transmission rate will be linearly at the 45°, which means the data which will be sent by host A is received by host D in the same transmission rate. Means transmission rate equal to receiving rate. R by 2 is the link capacity and lambda out will always be equal to lambda in. But at starting, when host A is sending some data and host B in meantime is starting to send some data delay will be increased. So delay will be increased by time exponentially. So as you can see that in graph, this will be the plot for the delay and transmission rate. After that, in scenario 2, finite buffers are being used in routers. It is more realistic scenario in which host A wants to send some data to host D, and in meantime host B is also want to send some data to host C with using routers and with finite buffers and link capacity R. Now if there is any retransmission, link will be unnecessarily occupied and there will be a loss of link or output. So as we can see that if there is retransmission, so ultimately if there are one packet sent by host A and one packet sent by host B, one packet sent by host B, so there are two packets. In natural way it should be transmitted only once. So transmission rate will be equals to receiving rate, which means lambda out equal to lambda dash in. Lambda dash in will be the original data rate or retransmitted rate. So if in case of, if there is a case of retransmission, the link will be shared for the same packet which is already sent, so there is a loss of output. So we need to reduce this output, which we will be discussing shortly in congestion control techniques. But their output will be reduced by r by 2 to r by 3. And if there is a duplicacy at the time of retransmission, so if in case there is a loss of acknowledgement and retransmission has been done, so there will be a duplicacy, and this link is really in unnecessarily used for retransmission. So packet will be duplicated at the end of host D or host C, and output will be further reduced to r by 2 to r by 4. So we can consider it with an easy example that if a father wants to drop his two kids to a school, and after reaching the school, a kid used to tell to his father that he has lost his assignment at home. Now a father has to go come back to home, and again he has to go to the school to give the assignment to his son. Now at this time, if there is retransmission, so extra petrol is needed to do this or retransmit the assignment. So the output will be, or petrol taken will be r by 2 to r by 3, means output will be decreased. Now if by in any case by chance his kid is having two assignments, and a duplicacy is formed at school end, then in this case the output will be further reduced to r by 2 to r by 4, because the petrol will be unnecessarily wasted. So this is because we need to use scenario 3, which we will discuss in next video, because it is quite lengthy. Till then, thank you.